I'm Santosh Birajdar, working in Tata Motors as a senior manager as a part of Engineering Research Center, Pune, India. The project which we started for the Zest vehicle, which we recently launched into the market, we had the information of the different ECUs, I/O interface circuits or ECU hardware reviews for the ECUs like instrument cluster ECU, body control module ECU, powertrain ECU. We got all the circuit related information from the suppliers and how we can simulate the vehicle related all these abuse conditions. So we were thinking of some simulation tool, and that's when we came to know about the Cadence PSpice, which we can use effectively. So what we want, we have to probably check the compatibility study. Along with that, we want to also verify ground shift conditions, jump start conditions, vehicle rated transient conditions. So all these conditions we wanted to verify without actually going into the physical validation as well as onto the vehicle validations. So all these worst case conditions we wanted to verify with respect to some sort of simulation tool. With steady state analysis, we verified tier 1 supplier information with respect to ECU specification table by using the Cadence PSpice advanced analysis, where we used Monte Carlo analysis for component tolerance variation, parametric sweep for temperature variation, then for example battery voltage variation, as well as the for the power dissipation and all. To understand the worst case, we use this smoke analysis as well as sensitivity analysis from which are very strong tools from the Cadence. As a OEM limitations, we faced a difficulty when we were doing the system level simulation, how we should go ahead. When my ECU is talking to some sensor or the load, that time we got a very good proposal from the Cadence. There is a SLPS tool where the information from the simulation or control circuit can be invoked from PSpice to the Simulink, which is from the MathWorks. So using these two circuits together as a bridging, we got a very good subsystem or system level simulation, where we again understood the transient analysis onto the ECU level and how these transients are feeding to another ECUs, where it can mess up to some other issues, and probably the vehicle level system study. So using all these tools, advanced analysis or SLPS or using the PSpice co-simulation activity, this helped us to do the complete system level simulation study and understand the risk much in advance before the design release, and help us in reducing the cost as well as the overall timeline of the vehicle SOP. PSpice models can be very easily found as nowadays, or you can find a lot of the tier 1 or tier 2 industries putting their PSpice code into the data sheets. You just take these PSpice codes and put it into your PSpice analysis, and you can build those models very quickly and very effectively and interface with other part of the circuit. So these are really very useful for us. IC manufacturers or vendors, they have the PSpice models available. We pull those models into the PSpice and we use them very effectively and build those models. If we do not have these models available, using the PSpice model editor capacity, we build these models and we accurately use these models in interfacing other part of the circuits. Now here onwards, we need to work together to build certain test cases, as well as when we consider as a system level simulation studies, as well as new challenges coming mainly into the functional safety areas, where a lot of ISO 26262 test cases we need to build together, as well as vehicle transient or EMC simulations, we need to work it together and achieve a great success together.